All right, IBSL1, we're back today to talk about exact values in the unit circle. So last class we talked about sine and cosine and a little bit of tangent going around the unit circle with radians and degrees, but we didn't talk about the exact values of those. We just kind of left them general, like sine of theta, cosine of theta. Today we're going to talk about what they actually are at certain points. We talked about 45, 45, 90s and 30, 60, 90s a few classes ago, but we talked about them in general. Like in general, we said like this is x, and x root 2. Which is true, but today we need to talk about some specific proportions for these special right triangles, because the unit circle is all about when the hypotenuse of your triangle, the hypotenuses, I'm not sure what the plural is, when it's 1. So we have to say that this is going to be 1, and this is going to be 1. Then if you do some algebra to solve for what the other sides would be, in the 45, 45, 90, this would be root 2 over 2, and this side would be matching root 2 over 2. In the 30, 60, 90, I always remember that across from the 30, there should be the smallest side, which is half of the hypotenuse, so this is 1/2. And then across from the 60 is the one that involves the root 3, so this is the square root of 3 over 2. If you don't have these two things memorized, put them down on a note card, really get them in your brain. I know I always say that you don't have to be good at memorization to be good at math, but TBH, when it comes to the unit circle, you gotta have these on lock, like pretty quickly. First up, find the sine, cosine, and tangent of 2 pi over 3. Well, first, I'm not going to convert 2 pi over 3 to degrees because that's silly. I just need to know where 2 pi over 3 lands in the circle. The one thing I do remember is that 2 pi over 3 is right about here, and, pi of 3 is about here. So if you count by pi over 3's, pi over 3 is 60 degrees, so 2 pi over 3 is going to land right here. So this is 2 pi over 3. Now, if I drop down to the x-axis and make a triangle out of this, it looks like this, where this is 2 pi over 3. Theta equal to 2 pi over 3. Now, pi over 3 is 60 degrees, which means that there is a reference angle right here of 60 degrees. Now, if I go back up to my 30, 60, 90 triangle right here and try to fit it into the unit circle, that means that this side is going to be 1. Across from the 60 is root 3 over 2. And right next to the 60, or across from the 30, is 1/2. Now, this is an almost accurate picture of 2 pi over 3 and the triangle that's in the circle because of 2 pi over 3, except for this guy right here. This 1/2, the cosine value, is in the negative x zone. It's to the left of the y-axis. So this needs to be negative 1/2. The height of the triangle is root 3 over 2, but it's still in a positive zone for the y values because it's above the x-axis, so we don't have to worry about that one. That one's positive root 3 over 2. Now, last lesson I talked about how sine of theta is the height of your triangle and cosine of theta is the base of your triangle. So, sine of 2 pi over 3 is root 3 over 2. That's this right here, the height of the triangle. Cosine is the base of the triangle, so cosine of 2 pi over 3 is going to be right here, the base, which is negative 1/2. Now, tangent, so here I'll start circling my answers. Tangent is slightly more involved because tangent of 2 pi over 3 is going to be equal to sine over cosine. So sine of 2 pi over 3 over the cosine of 2 pi over 3. So this is equal to root 3 over 2, all divided by negative 1/2. Now, if you take the top and leave it the same, and then if you're dividing by a fraction, you do the old multi-flip. So you keep the top as root 3 over 2, and then multiply by 2 over negative 1. So this equals negative root 3, because the 2's cancel out. So tangent of 2 pi over 3 is equal to negative root 3. So far, so good on that one. Next one, find sine, cosine, and tangent of 5 pi over 4. You guys, for any problem like this, I always draw a fresh unit circle. I know that in some classes, you may have had like a master sheet next to you where you fill out every single spot and then you just keep that by your side. I don't think you guys need that. I think that you just need your special right triangles and then knowledge of the unit circle. So every single time I draw a quick circle and then I actually sketch it out, even if the directions didn't say to. 5 pi over 4. So let's think about pi over 4s. Pi over 4s are the same thing as 45 degrees. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So here's 5 pi over 4. Here's the triangle that it makes. Here's the base. And this rotation here is 5 pi over 4. Now, pi over 4 has a reference angle of 45 degrees. So that means this angle is 45 degrees, and so would the other angle in the triangle be 45 degrees. So that means the sides of the 45 degree angles, or the 45, 45, 90, are root 2 over 2 and root 2 over 2. But please notice that both this side and this side are in the negative x direction and the negative y direction. So both of these are going to be negative. Now, sine is the height of that triangle, even if it's a negative height. So that's sine of 5 pi over 4 is negative root 2 over 2. Cosine is the base, which is the same number, because this is an isosceles triangle. Negative root 2 over 2. And then tangent of 5 pi over 4 is going to be sine over cosine, so negative root 2 over 2 all over negative root 2 over 2, which is just the same thing, so this becomes tangent of 5 pi over 4 is 1. So here's our answer. Here's the sine is negative root 2 over 2, the cosine is negative root 2 over 2, and the tangent is 1. You guys, think back to last lesson where I talked about how the tangent is not only sine over cosine, it's not only y over x, but it's also rise over run, which is slope. You guys, if I just gave you this line right here, wouldn't this have a slope of 1? Because it goes like up a unit over a unit. It's a 45 degree slope. It's a slope of 1. So that makes sense. There's also a matching one in quadrant 1 that if you were to extend this line, that would mean that like this triangle right here would also have a tangent of 1. So whatever angle this is, which is pi over 4. So tangent of pi over 4 is also 1. Fun fact. Okay, now we're going to work backwards. Sine of theta is root 2 over 2. Solve for theta, but we're going to solve between 0 and 2 pi. Here's where students will get in trouble. They'll look at that and say, oh, jolly, I know, I got you. I know how to undo a sine. You just do a sine inverse. So I can do on my calculator sine inverse root 2 over 2, and then I can get an answer that way. Which is true, you can get an answer that way, but it's not the only answer because your calculator is lazy and only looks for one answer when on this interval there can be multiple answers. So here's what your thought process should be. The fact that this involves a root 2 over 2 means that it has to involve a 45, 45, 90 triangle. The fact that that's positive, sine is positive, that means that it can't be in this quadrant or in this quadrant because sine is only positive above the x-axis. So it has to be in one of these quadrants. Root 2 over 2 is a 45 degree reference angle. So that means it could be here, where this is root 2 over 2. So this spot is pi over 4. But if you take that triangle and flip it into quadrant 2, there is a matching triangle over on this side. Where this also has a height of root 2 over 2. So if you're counting by pi over 4s, this is pi over 4, 2 pi over 4, 3 pi over 4. So those are your two answers between 0 and 2 pi. There's two spots where the sine value is equal to root 2 over 2. Theta is equal to, and we'll put them in ascending order, pi over 4 and 3 pi over 4. Very similar problem. Cosine of theta is negative 1/2. Solve for theta on 0 to 2 pi. Well, cosine is negative, which means cosine is positive in quadrant 1 and in quadrant 4. So we know that our cosine has to live in one of these two, or both of these quadrants, actually. The fact that this is a negative 1/2 makes my brain realize that it involves the 30, 60, 90, because the 30, 60, 90 is the only one that has a side of 1/2. Now, if the base is 1/2, that means that it would be something like this. One half is only involved with the 30, 60, 90, and it's across from the 30 and next to the 60. So that means if I were to draw this triangle, that the 30 would be up here and the 60 would be right here as a reference angle. Now, if you count by 60s, let's see. 60 is pi over 3, so this is pi over 3, and this is 2 pi over 3. So that's one spot where it happens, but if you take that triangle and reflect it down into quadrant 3, there is another one right here that has that same base of negative 1/2 that they share. So if this is pi over 3, 2 pi over 3, 3 pi over 3, this is 4 pi over 3. So theta equals 2 pi over 3 and 4 pi over 3. Last one. Solve tangent of theta equals negative root 3 over 3. Okay. First of all, we're going between 0 and 2 pi. Tangent is a slope. So if you think about the slopes of the hypotenuse, like if you have a slope here of the hypotenuse, this is a positive slope. So since our slope is negative, it can't be there and it can't be here either, because this would also be a positive slope. So both of those quadrants are out. Not here, not here. Negative slopes are going to happen in this quadrant and in this quadrant. Slopes of the hypotenuse. Now, the fact that it involves a root 3 over 3, like there's a root 3 in it, makes me think that it involves a 30, 60, 90, not a 45, 45, 90. Now, what else? Tangent is sine over cosine. So we really have to figure out if it was 1/2 divided by root 3 over 3, or if it was, root 3 over 2, if it was 1/2 divided by root 3 over 2, or root 3 over 2 divided by 1/2. So let's explore the first option. If it was 1/2 over root 3 over 2, this would be 1/2 times root 3, times it upside down, which is 2 over root 3. The 2's cancel out, and you're left with 1 over the square root of 3. But 1 over square root of 3, you haven't rationalized your denominator. So you need to multiply the top and bottom by root 3 over root 3. And then root 3 on the bottom squared is just 3, and you're left with a root 3 on top. So this is root 3 over 3. So we found it. It's not root 3 over 2 divided by 1/2. It's 1/2 divided by root 3 over 2. Which means that this is your sine of theta, and this is your cosine of theta. But one of them has to be negative and one has to be positive in order to get that negative right there. So let's see if I can draw this. The sine has to be 1/2, which means that it's across from the 30. So here's your side of 1/2. That's across from a 30 degrees. And this side would be root 3 over 2, but it's in a negative zone for cosine, so or in the negative zone for x's. So let's think. This reference angle right here is pi over 6. 30 degrees is the same thing as pi over 6. So that's pi over 6 back from 180. 180 is like 6 pi over 6. So if you back it up 1, that means this spot is 5 pi over 6. So that's one of our answers. That means tangent of 5 pi over 6 has negative root 3 over 3. Now, here's the trick with tangent, is that the slope here is going to be the exact same if you continue it all the way through to quadrant 4. So the other triangle would be this one. Where this is a reference angle of 30 degrees, or not degrees, let's say a reference angle of pi over 6. So we could say that that angle is negative pi over 6 because it went this direction, but the directions say that it has to be between 0 and 2 pi. So what you need to do here is think of the 2 pi spot all the way around the circle is the same thing as 12 pi over 6. So if you take 12 pi over 6 and you back it up 1 to here, that means that you took a pi over 6 off. So this is 11 pi over 6. So our final answers are going to be 5 pi over 6 and 11 pi over 6. All right, you guys. Attached is a worksheet for you guys to work on. It is not from our book. Answers should be included. Good luck. And have a great rest of the year, BTW. You guys have been